Welcome to UC Science Radio, where we conduct interviews with a range of scientists to learn about the big issues facing our world and what science is doing to help. I'm Molly McGidd, a master's student in the School of Biological Sciences. Today, I'm talking with Dr. Ben Kennedy. He's an award-winning professor and an internationally recognized volcanologist who travels to the world's volcanic hotspots to understand the science behind eruptions. He says his research and teaching are driven by a love of volcanoes and fueled by projects that are fun, exciting, and important for society. Kia ora, Ben. Welcome to UC Science Radio. I'm curious about your role at UC. So what do you do and what's your research about?
Kia ora, Molly. I am a volcanologist, so I research volcanoes and why they erupt. I also do a bit of research into how students learn, and specifically how students learn geology and volcanology in the field.
And what was your path to this research?
I always say my path to this is I'm a kid that never grew up. I always liked playing with rocks when I was a kid, smashing rocks with a hammer, looking for crystals and fossils and things, and also blowing up and dreaming of lava running down the flanks of volcanoes.
Yeah, so you've kept that energy up. And it seems like in your lab, that's sort of some of the methods that you use, smashing rocks and melting them down. Could you talk a bit about how you create the conditions of a volcano erupting, but in a lab setting?
Yep, we've got a few different labs here at the University of Canterbury. We've got ones that work at high temperature, so where we can actually melt rocks and create temperatures that you see inside a volcano and make our own lava, which is a lot of fun. We've also got high pressure labs where we can raise the pressure so it's equivalent to deep inside the earth, where gases and lava and magma is moving around inside the volcano. And we've also got specialist machines that can measure the exact amount of stress and strain that exist inside the earth, see how strong rocks are, to see when they break, see when gas can travel through the rocks versus when they get blocked up.
I've seen that a lot of your current work has to do with drilling into the magma chamber of a volcano. So first, to back up a bit, what is a magma chamber? What part of the volcano is it? What does it do? And then also, could you talk a bit about your work actually drilling into the magma chamber?
Yep, so under most of our volcanoes in New Zealand and all over the world, there is usually some magma, which is kind of the fuel for the volcano. So this is the lava that's underground, and this magma can be in various states. So it can be mostly liquid, it can be mostly crystals, it can have gas, it can have no gas, and that may depend how long it's been sitting there. Under different volcanoes, so for example, under a very large volcano, you may have a very large magma chamber, and under a small volcano, you may have a small magma chamber. And yeah, so you asked me about drilling into magma chambers. So we don't really know what magma chambers look like. It's kind of like the final frontier. We're geologists, we've been to the bottom of the ocean, we've been to the top of the highest mountains, we've flown around in space and sent satellites out into the solar system and what have you. But we've never been into a magma chamber, so we don't know what it's like. And so there is a big international project to go to Iceland, to a volcano there, where a geothermal company accidentally drilled into a magma chamber. So they drilled into it to extract heat and to generate geothermal energy. And they initially did it by accident. So they were not expecting to have magma rising up their drill hole. They were, just trying to get hotter fluids to run their power stations.
So sort of taking that initial mistake and then saying, can we actually do this for a research purpose?
Exactly, yeah. So they were trying to go back better prepared, and they've got a big team of experts from around the world to help them out with this project.
And you mentioned that they were actually trying to get geothermal energy from that volcano. Can you explain what geothermal energy is?
Yep, so geothermal energy, it's used differently in different parts of the world. So in some parts of the world, power can be generated by simply pumping cold water down into the earth where it is warmed up by the fact that deeper in the earth, temperatures are higher. So it warms up that hot water, turns it to steam, and the steam can then turn turbines, generate energy. In volcanic regions like New Zealand and Iceland, the water and the steam is already down there and is already very hot, and you literally just stick a drill hole down and out comes the steam and the hot water ready to directly generate energy.
So that's a renewable energy source that we can take advantage of in areas with a lot of volcanic activity.
Yes, yeah, it should be sustainable, and if operated properly, you can keep these resources going for very long amounts of time.
Your work has taken you all over the world, seeing volcanoes in many different places. Could you talk a bit about your work globally and what has been the most interesting things that you've seen in the field or that you've been able to do research on?
Yeah, I'm pretty lucky. Volcanoes tend to be in pretty exotic places. So I think in the last 5 years, I've probably been out to Chile and hiked up active volcanoes in Chile with a group of my grad students. We were trying to work out whether certain eruptions were triggered by earthquakes or not. I've been out to Vanuatu and seen erupting volcanoes there, trying to help the Vanuatu team have a better understanding of where molten bombs land around a volcano that's a tourist destination there, Yasur volcano on the island of Tanna. We were using drones to map where these bombs were landing. We also have been out to Japan as well, also thinking about where bombs have landed during recent eruptions, again to help with hazard mitigation. Iceland, obviously, with the magma drilling project. So I had a lot of fun going to Iceland. And we also had a lot of fun because we did a virtual field trip with schools. So I had a backpack, literally a backpack full of cuddly toys from various schools around New Zealand, as well as kind of 6,000 students who would kind of come along with us on the trip, and we had to have evening Zoom Skypes like this with various schools around the country and their cuddly toys.
That seems like something that could be used right now where people are all looking for something to do virtually, these virtual field trips and seeing, perhaps videos of volcanoes erupting or things like that.
Yeah, definitely. I mean, this is something that me and the group here in the university are thinking a lot about is, how to use these virtual experiences now in this time of lockdown and how to do it better. And we've actually just a few days ago, I had a Zoom session with 230 academics from around the world where we gave a little webinar on how to do virtual field trips, drawing on those experiences working with New Zealand school kids.
Wow, that's really cool. You said that you were working in Chile, trying to figure out whether earthquakes could trigger volcanoes. Can they trigger volcanoes, or what did you find?
Yeah, it's a very good question, and we're still actually struggling to answer it. What it looks like is that certain volcanoes, under certain conditions, can be triggered by earthquakes, but it's actually rarer than you might expect. Yeah, I've got some of my grad students here have been looking into exactly what type of volcanoes are most likely to get triggered. And it looks like this one in Chile that we were working on, which is Cordon-Caye, that this had a very big eruption just a day after one of the biggest earthquakes in kind of human history. So that one's a good candidate. And we were actually looking at the bubbles in some of the bits of pumice. We're trying to work out whether there was something special about these bubbles to indicate that they'd been shaken.
And how well can you predict certain things about a volcano? It sounds like you may be able to say where lava is more likely to land, but what about predicting when a volcano is going to erupt, or when we might expect something like that to happen in certain places?
Yep, so my research is pretty useless at predicting when what we've focused on is looking at, where things have happened in the past. But we do work a lot with the teams like GNS Science, who are the ones monitoring the volcanoes, and it's that monitoring which you use to then say, okay, you're getting more and more earthquakes. This may help forecast that eruption is more likely at this time. But yeah, we work closely together, but it's that real-time monitoring data that's used to predict when.
So I know you've done some work on White Island and have looked at the eruption in 2016, but I'm interested in what your response to the recent eruption was, both as a scientist and also as a person.
So it was really weird for me, to be honest. A little bit emotional. I've been working on White Island for more than 10 years, and I knew the guide Hayden who died. So it's been quite hard for me to kind of separate those two things. But now I'm kind of, I guess I've processed it all a little bit more. I was out of the country when it all happened as well, which made it also weird for me. But now I'm getting back into looking at my research there and working again closely with GNS Science. So, and in fact, I just finished off the work. There was an eruption in 2016, and I'd worked with a bunch of students on that, and we worked out that there are some of the cracks inside the volcano. So a lot of blocks of material that got thrown out during 2016 and landed as blocks impacting all around the crater floor. We collected some of those blocks and we did some tests on them, and we discovered that because they were all kind of encrusted in minerals from the hot hydrothermal system of the volcano, and they were all cracked, we worked out that some of these cracks were behaving like valves, so opening and closing again. And this was one way that the volcano had been modulating, releasing pressure. And there was also implications that some of these minerals that were growing were ways that the volcano was also blocking up and blocking these valves so pressure couldn't be released. So yeah, so it's nice to finally finish that work from 2016, and now we'll be looking at the data about the 2019 eruption and obviously the tragic events that surrounded that. So that's to come.
And in more of a lighthearted tone, I know that some of your work has been developing things like games to help both students, but just people in general learn about science. So what is that process like, and how do you think there's a role for fun and games in learning?
Yeah, I mean, I think I'm probably unusual compared to a lot of scientists, where I really am motivated by fun. I do my research on things that I find fun, and I think a lot of people are also motivated in the same way. So if we can make learning fun and make research fun, then more of us will want to spend more time and more energy doing that. So yeah, we have fun developing these games that make learning about science more fun. So
Can you talk specifically about the game? I think, is it called Drilling into Magma? Is that one of the games that you made?
yeah, we've got a game called what's it called? Magma Drillers Save Planet Earth, and that was a game that we originally developed for school children, but actually turns out that university students also enjoy it and can learn a lot from it as well. I managed to persuade a bunch of my colleagues to dress up in crazy outfits from the 70s and the future and role play what it might be like to take part in drilling into magma. And then we made the students also role play those roles, and they have to work as a team to try and drill in the right place to get out magma thermal energy and save the planet, and not start an eruption that might destroy the planet.
And it sounds like it's not just fun, you're actually using real scientific knowledge to back up these cases and scenarios, because clearly people are thinking about how do we do this safely, what's the best way to proceed.
Yeah, we use actual data, and the decisions that the students are making are the exact same decisions that we, the scientists, are making now, and this is a real project. And it lent itself so much to a game because it sounds like a ridiculous scientific, like a bad science fiction movie. So that's ideal for a game to get kids excited about science.
One story that I've heard that I'm just curious to hear whether it's true or not is that the Prime Minister thought you were a first-year student when she visited the university. Is that true?
Yeah, that is true. Yeah, that was an entertaining moment. So that was when she was here opening the new science building, the Rutherford building, and I was doing a demonstration for using basically a sand volcano with some Lego men, but I was wearing a volcano hat on my head that one of the students had made for me. And I think I was probably characteristically wearing shorts and a t-shirt. And then when the Prime Minister was giving her speech, she asked, can someone volunteer to help me open the building? And nobody said anything. And then she said, how about you? We need a first-year student, and pointed at me and then dragged me up on stage, and I had to help us set off the fireworks.
That's pretty funny. That's probably something to do with you just really having fun and engaging with projects. She thought you must be a student.
Yeah, exactly. I think it's a bit of the way I dress and the way I behave and the way I look. Yeah.
My last question is, so right now we're in lockdown and may not be able to do quite as many things, but I'm interested in learning what you're looking forward to doing next. What's the next project or next thing that you're excited about?
Catching up on all my work that I'm behind on is probably the first thing that needs to be done. I'm a little bit behind, but we do have plans to go back to the volcano in Vanuatu, to Yasur, and then we want to test out methodologies to remotely sense the thickness of ash. This is one student I'm working with on this project. So can we work out